Hmm. Can you hear me? Hello. Oh, hey, what's up? Cool.
Hey Thatcher, did you have questions or are you just checking out to make sure you can sign in? Okay, go ahead and you can type your questions in on the.
Yeah, so my questions were just like I didn't really understand the statement, like the proportional statement. So, yeah.
Okay, give me just a second. Let me get the screen pulled up, okay?
Okay.
Okay, Thatcher. So when we're looking at these problems 3 through 5, the directions say to list all pairs of congruent angles for the figures. So that's the first thing. Were you good with that part?
Yeah, I was pretty good with that part.
Yeah, I was pretty good with that part.
Okay, so then the next part is to write ratios of corresponding sides in the statement. Statement of proportionality. So that means you're going to have to figure out what sides go together. And remember, that's where your similarity statement comes into play. So if we look, A and B are the first two sides or the first two angles listed in that similarity statement, and then L and M.
Okay.
So AB and LM are the same, or they're the similar sides, right? They correspond with each other.
So then
That would we would put the bigger side over the smaller side, kind of.
Yeah, that's fine. You can put the big triangle over the small triangle, or the small over the big, as long as you keep it the same.
Okay.
And then you're going to go to the next set of sides, which you could say are BC and MN. So BC and MN here.
Okay.
And then you'll do it again for the last two, which is AC and LM. Okay.
Okay, and then
So you'll have all three of those set up. So it'll look something like AB over LM is equal to over MN is equal to AC over LN.
Okay.
Does that make sense?
Yeah.
Okay.
And then that's just the similarity statement.
That's the statement of proportionality.
Okay.
Because
Statement.
that sets up the proportions. Yeah, that sets up the proportions for all of the sides.
Okay.
And then you'll just do the same thing again for 4 and 5.
Okay.
Okay, Madison, here's number 9. And what you're supposed to do for number 9 is find the scale factor of JKLM to EFGH. So the scale factor, remember, is the proportion or the ratio, from one side to the other. So if you look at those two figures, if we take this smaller figure and turn it, then we'll have the same figure as this one, just smaller. So it would be 8, 11, 3. This side's listed as Y. So then we can see that we have 8 and 20 are two sides that we have measurements for on both. So we could set up that scale factor. It wants JKLM to EFGH. So JKLM is going to be on the top. So that's going to be 20 over 8. And then that would reduce. And the reduced form of that is your scale factor. And then let's see. Is that good, Madison? Okay, good. Natalie, 21 through 25. Okay, Natalie, so for 21, you're supposed to, we're comparing two triangles, okay, that are similar. We have triangle NPQ and then triangle RST. All right. The side lengths of NPQ are 6, 8, and 10. And the length of an altitude is 4.8 inches. So we'll just say 4.8 there, okay? The shortest side of RST is 8 inches long. So if we're saying that these triangles are similar, then the shortest side is going to have to be the same as the shortest side for our other triangle, which would go here, okay? Does that make sense so far? Okay. So what we have two sides of, or we have, let's see, we have two corresponding sides on similar triangles, okay, 6 and 8. So we can make our scale factor now. So what's the scale factor there? Yeah, 3/4. Now we can use that to figure out the lengths of those other two sides because we'll set up proportions. We'll say 3/4 equals something, or sorry, 10 shouldn't go on the bottom because 3 comes from your smaller triangle and 10 is going to come from your smaller triangle. So it should go on top. So then we'll solve for this. Does that make sense? And then you'll do the same thing with that 8 side. So you'll say 3/4 equals 8 over something. This is that side, and this one is that side. So you're going to do something similar to that for all of those problems, okay? So look at them and see if you still need help, okay? Let's see, Megan, number 18. Let me go back. Okay, hold on, Abby. All right, Megan, so for number 18, the scale factor of A to B is 1 to X. And then it asks you what's the scale factor of B to A. So if we think about that, A to B means the first one should relate to A, so that 1 should be for A, and that X should be something from B. So if we're going to flip that and make it B to A, then it should be X to 1. Does that make sense? Okay. All right, Abby, which one are you lost on? $21. Okay. So let's see. I'll see if I can pull my beautiful artwork back up.
Beautiful artwork, you know.
Beautiful artwork, you know.
No, it didn't save it. Okay, so for 21, remember we're dealing with 2 triangles, so draw your triangles, okay? Start out there. We have triangle N, P, Q. And then we're going to have another triangle, which is R, S, T. Okay? Thatcher, your class has a different lesson plan than Abby and them. So if those are not problems that are on your lesson plan, then you're good. Okay, Abby, so you got your triangles drawn? Yeah, Natalie, first and second period are doing different than third period. Okay, Abby, so if we label our sides, then we have sides that are 6, 8, and 10. Okay. Now, the other triangle, it tells us that the smallest side is 8 inches long. So we want the smallest side of the other triangle to be the same or the corresponding side with the smaller triangle. So this will be 8. We'll just make the triangles look the same, okay? Does that part make sense? Oh, she left. Oh, you're back, Abby. Does this make sense how I have the sides labeled here? Okay, so now what we're going to do is we're going to make up that scale factor, okay? So in order to make the scale factor, you have to have a side from one triangle and a side from the other triangle, right? So if we set these up, these are the corresponding sides that we have. A 6 from this side and an 8 from this side. Those are corresponding, okay? So that scale factor reduces to 3/4, okay? Your scale factor should always be reduced. Does that make sense? Okay, so now we're going to take our scale factor here of 3/4 and we're going to use that to set up the proportions, like what we did in the very beginning of class yesterday, to solve for those other sides. So if we have a scale factor of 3/4, we know the other sides that we're looking for are here and here, right? And we can say that these two sides are similar and these two sides, okay? So let's start with that side. The 3 of our scale factor came from the smaller triangle, so we're going to put that smaller triangle side on top. So we'll do 8 over x. Now remember, you're going to cross multiply and then divide by that to come up with your missing side, your other side. You get it now? Your light bulb went off? Okay, so you're going to do that for all of those in one way or another, okay? Let me know if you have problems on the rest of them. Just let me know. Number 26, Sarah, hold. Okay, so number 26, Sarah. For that one, you'll have to find the area of both triangles and then to compare them. Really comparing them, you're just going to kind of see if there's a relationship between the two of them. Like, is it double? Is it half? Is it squared? Something like that. Does that make sense, Sarah? Okay. Okay, Jake, so for 21 and 22, we have two triangles. So the first thing you're going to want to do is draw your triangles and label them, okay? So you're starting out with triangle NPQ, and then another similar triangle RST. We know the sides of NPQ are 6, 8, and 10. And then we know one of the sides, or the shortest side of RST, is 8. And the first thing it wants us to do for 21 is to find these other two sides, okay? So what you're going to have to do is set up your scale factor. So you have your shortest side of this triangle and your shortest side of this triangle. So you can make a scale factor out of that and say that that's 6/8. And remember, your scale factor needs to be reduced, so that would reduce to 3/4. Now you're going to use this to set up your proportion to find your missing side. So 3 in your scale factor comes from the short side of the small triangle. So if you have 3/4, you can say that that's equal to another one of the small triangle sides, 8 over this other side here. And then you cross multiply here, divide, and that gives you this side. And then you'll do the same thing to find the other side. Does that make sense? You're welcome. Yeah, Isabel, let me pull them up, okay? So Isabel, for number 9, you're supposed to find the scale factor of JKLM to EFGH. So you're going to have to either redraw one of the figures or flip it mentally so that you can kind of see which sides correspond to which sides. That way you can make your scale factor. You need to see which two sides you have measurements for on both figures, okay? So if you look at that, you can see that EF and JK would both be similar, right? EF here and then JK here, they would be the same side. So you could make a scale factor. It wants JKLM to EFGH. So you're going to put JKLM first, or the measurement from that figure first. So it'd be 20/8, and then reduce that. And that would be your scale factor. And then you'll use that scale factor to solve for the other sides by setting up a proportion. Does that make sense? Okay, good. So Abby, for 21, you're going to have 2 answers. Because you had to find the other 2 sides. You're not dumb. Okay, and then Isabel, you also had a question about number 18. So for number 18, you're doing the scale factor of figure A to B, and that's 1 to X. So 1 should be from figure A, and X should be from figure B. So if you're going to do it, flip it around and do it from B to A, then it would be X to 1, because X corresponds with figure B, and 1 corresponds with figure A. Does that help for that one?
Whoops.
Okay, Madison. For number 22, it's going to be the same type of thing that we did for 21, except you're going to use that 4.8-inch altitude instead of one of the other sides. So if you have, we said our scale factor was 3/4. So we have a 4.8-inch altitude on one, and we need to solve for the altitude of the other. Does that make sense? Okay, good. Okay, Devin, number 32. You're preparing a computer presentation to be digitally projected onto the wall of your classroom. Your computer screen is 13.25 inches wide and 10.6 inches high, and the projected image on the wall is 53 inches wide and 42.4 inches high. Are they similar? And then if so, find the scale factor. So what you need to do is you're going to have to draw your pictures and label them, okay? So you've got your computer screen and then the wall of the classroom, okay? Drawings are not to scale. So your computer screen is 13.25 wide and then 10.6 inches high, right? And then it says that the wall is 53 inches wide and 42.4 inches high. So what you're going to have to do is set up your ratios of the corresponding sides. So you're going to set up a ratio of this side to this side, and then this side to this side, and see if those scale factors that you get or if those ratios that you get are the same. And if they're the same, that says that those shapes are similar. Does that make sense, Devin? Okay, good. So Abby, for 22, you're going to use that same scale factor that we figured out for 21, that 3/4. And then the altitude, remember the altitude is just dropping a line from the vertex of one side down to meet perpendicular, or the vertex down to meet perpendicularly with the opposite side, okay? Yes, Natalie, it is that red line in those diagrams. So you're just finding, Abby, another proportional part of the triangle. So you're going to use that same thing, and it tells you that you have an altitude in the first triangle in NPQ of 4.8 inches. So you'll have 3/4 equals 4.8 over x. And that x that you're going to solve for is the altitude of the other triangle, RST. Does that make sense? You're welcome. Madison, number 22 just has one answer. You're welcome.